all of these conversions that I give for part 3 might be useful for any of the problems where we're doing some calculations. So these apply to all of part 3. And I think maybe a couple problems in part 4. I'm not sure. Let me just double check. No, we don't necessarily need this for part 4. We have this luxury plane, and we want to know how many hours it would take to fly one astronomical unit. Just to be clear, the speed's already given in miles per hour. So if I take miles and divide it by miles per hour, that'll actually get me the distance. If you really want to be specific, that's you use d equals r times t, and for d, we'll put in 93 million. And then for r, we'll put in 1,350. And when we actually work out this number, it ends up being about 69,000 hours. Again, I'm rounding here. And then when we want to know how many days this will be, now we're just going to convert units. So we'll take 69,000 hours and divide it by the 24 hours in a day. This is giving me about 2,900 days. Again, I am rounding compared to what you'll see in the answer key. And then if we want to get a number of years here, we'll take 2,900 and divide it by 365. Whoops. I don't know what that was. Whoa. That was not what I wanted. Okay. Pardon me, folks. Technical difficulties. All right. 365.25 days. And that's going to give us about 8 years when we round. All right. Now, the Voyager spacecraft is moving at about 11 miles per second. So if you want to know how many seconds it takes to move a light year, you can put either of these numbers in your calculator. If you're familiar with scientific notation, I'll put 6 times 10 to the 12th. Okay. Now let's just be clear. That's the distance. We've got a rate of 11 seconds, and t's the time. So when we isolate t, we're going to get 6 times 10 to the 12th divided by 11 miles per second, and that's going to give me 5.4 times 10 to the 11th seconds. Next, we want to know how many minutes this is, so we'll take our, and this is seconds. We're going to take our seconds, and we're going to divide it by 60 seconds in a minute, and that's going to give me about 9.1 times 10 to the 9th minutes. That's about 9 billion minutes. And then we're going to take these minutes and divide it by 60 to get the hours. So 60 minutes to an hour. And that's going to give me about 1.5 times 10 to the 8th hours. To get this into days, that's 1.5 times 10 to the 8th divided by 24. And so that's going to give me about 6,250,000 days. So that's hours. And then finally, when we take these days and divide it by 365.25, that's going to get us into years. So we'll divide by 365.25 to get the number of years. That's getting me about 17,000 years. All right. Now here, Mars is about 0.52 astronomical units away from Earth at its closest. Let's just get that into miles up here. So 0.52 times 93 million. Again, because an astronomical unit is about 93 million miles. It's getting us about 48,360,000 miles. Now, we launched a spacecraft at Mars at a speed of 20,000 miles per hour. We want to know how many months it'll take to get to Mars. I should have been clear here. I don't know if I wrote it in the previous thing with my unit conversions. I should have said that 1 month is about 30 days. So I will actually add that to the various formulas that I give you for part 3 of this little quiz. So now we're going to say distance is rate times time. Our distance is 48,360,000. And then our rate is 20,000. And our time is the unknown. So when I actually get my time, that ends up being 2,418 hours. I want to get that into days, so I'll take 2,418 and divide it by 24 to get the days. But I don't want to stop at the days. Let me divide by 30 to get the number of months, and that's going to give me about 3.35 months. All right. Now, how many months would it take the same spacecraft to travel 1 light year? I ended up getting about 417,000 months. And I'm going to actually leave you to work this out. So if you're curious, shoot me an email and check with me on this, Jesse. All right. Now, it says, use your answer to part C to explain why current technology would make it so hard for humans to colonize anywhere outside the solar system. So if we look at the numbers, okay, within the solar system, takes months. To other stars traveling takes takes tens of thousands of years. There is no way we would ever make it. That's it. I added a few things in the answer key, but this is really the essence of what we want. Now here, it says, how much time does it take take a beam of light to reach Earth from the sun? So we're going to take 93 million miles, which is an astronomical unit, and we're going to divide that by 186,000. I'm doing this rather quickly. Let me just be clear. Distance is rate times time. We're trying to get the time. Our rate is 186,000 miles per second, and the distance here is 93 million miles. So when we actually isolate t, I'm getting about 500 seconds. And if we want to convert that into minutes, that's 500 seconds divided by 60. It's getting me about 8 minutes when I round. So if I want to know how long it takes light to reach Earth, take light from the sun to reach Neptune, okay, I guess we could say 30 or 31. I'm just going to use 30 because it's easier. So we can say, if you want to be technical, we should say 31 AU. I'll just say 30 AU times the 500 seconds we got before, and that's about 15,000 seconds. And you know, I should say 30 AU from the sun. I should just correct that on the thing, and I'll be careful that I do that on the quiz. So it's 15,000 seconds, and then if we want to know how many minutes that is, we'll take this and divide it by 60, and that's getting us about 250 minutes. And we'll divide 250 minutes again by 60 to get hours. And that's getting us about 5.6 hours. All right. So that is part 3 of the test. We'll take a look at parallax in part 4.